Good afternoon. My name is Irfan Pottachola. I'm from the Netherlands Institute of Applied Scientific Research, also known as TNO. What we're seeing today is industrialization is increasingly being positioned as one of the key solution directions for the productivity challenges that we have. And what we are also seeing today is that there's a lot of technologies, and despite these technologies, the widespread adoption is quite limited. And in this presentation, we are going to look at some of the enabling conditions that could perhaps change the situation. To sort of contextualize this study that we are doing today, the Dutch infrastructure sector is entering a period of quite unprecedented demand due to aging infrastructure. What we see is that about the annual renewal cost is expected to rise to about 3 billion. And it's going to last like this for this whole century. And much of this assignment is on bridges and viaducts. About 40% of these assets are entering its end of service life. And this puts significant pressure on the market. And what we see is that the market is already operating close to its capacity. And just like my namesake Irfan presented earlier, that we have to do more with less people because of the labor shortages and aging workforce, etc. And on top of that, construction is primarily fragmented, project-based, which also means that the productivity improvements are quite limited. So together, this creates a very simple problem that the growth of the renewal demand is growing in a much faster rate than what the productivity can do in the current way of working. And this means that there should be new ways of working, which is more productive. This is where industrialization is normally positioned, right? Industrialization in the housing has proved its value to reduce lead times, to reduce costs, etc. And similar approaches are also coming up in the infrastructure sector. In the Netherlands, we have industrial, flexible, and demountable bridges, modular bridges, let's say, has been demonstrated to reduce the on-site delivery, to reduce the lead time, to reduce costs, and also to have huge economic benefits. But what we see on the other side is, despite this potential, the adoption is quite limited. And this is more of a coordination and a collective action problem. What we see, or the reality, is that the construction is quite demand-driven, infrastructure sector more so. And in the Netherlands, we have more than 370 asset owners. This basically means that all of them have diverse requirements, diverse priorities, because of which decision making is quite fragmented. And a lot of these organizations want to industrialize. They want to change the way they're working. But what we see is that all of them have their own perspectives on industrialization. And these perspectives are often associated with downstream technologies. And there is a little less attention on what is the systemic condition required to allow for industrialization technologies. And this objective is, or this observation is what led to our objective of this research, which is to identify the fundamental principles that enable industrialization of infrastructure asset management at scale. We did this through a thematic analysis of scientific literature, mostly from the housing sector, contextualized to the infrastructure context. And we mostly looked at goals and enabling conditions of industrialization technologies. And the resulting principles were validated with experts, both from the market and from asset owners. Before talking about the principles themselves, it's quite important to conceptualize industrialization, because I'm pretty sure all of us have different definitions. We define industrialization of asset management as a coordinated reorganization of the infrastructure sector in order to reduce its project-based and demand-driven nature. And we do that to achieve economies of scale and to reduce transaction costs. And most importantly, to implement and enhance process-oriented technologies that can improve the productivity of the construction sector in general, but also of infrastructure. And this is the lens through which we looked at the principles. So what can this reorganization be based on? What should be the enabling conditions for this reorganization? And from this perspective, we defined 5 principles of industrialization. First one is the principle of continuity and repeatability. This is the principle of ensuring continuous operations over time, continuous and predictable demand over time, let's say, in such a way that there can be repeatable supply. So this creates the market certainty, or the certainty that the market needs to invest in repeatable products and processes. If you have continuous processes, it allows organizations to specialize, allows them to narrow their expertise and resources on specialized scopes of process and services, or products and services. This reduces portfolio complexity and, on the other hand, improve the efficiency and quality of those products and services. A continuous improvement is quite essential for any industrial system, and knowledge codification embodies that principle. And it's really basically about embedding and capturing and embedding tacit knowledge into structured system for knowledge retention and, most importantly, reuse. The fourth principle is the principle of pre-engineering, and this is the idea of developing reusable products and processes through standardization and pre-definition. It reduces the bespoke project-based engineering in infrastructure projects, and that can significantly improve the market productivity. The last principle is on socio-technical alignment. This is because industrialization requires achieving alignment between social systems and with technical systems. For example, if you have a nice technology, there should be enabling procurement strategies in order to enable that technology. And this principle allows for coordinated resources and a bit of a coherent system performance. What we see is that these principles are not independent, that those are quite interdependent, and this interdependency leads to, let's say, three key insights. The first one is that industrialization should be approached from a system perspective. Right now, it's quite mostly looked at from a production logic perspective, but it needs to look at it from a system perspective, meaning we also need to look at the organizational logic and institutional logic of the infrastructure sector. This is because technologies requires enabling conditions, and the principles can help explain why certain technologies, despite successful demonstrations, have not scaled in the industry. And the principles also really points our fingers to the asset owners, and in the infrastructure sector, asset owners quite importantly shape industrialization. What we see is that at the moment, industrialization is pushed to as a market responsibility. But if you look at the principles, the key principles of continuity and repeatability and socio-technical alignment is enabled by demand-side decisions, let's say. Now, what do we do with this? This principle can be used as a framework for several processes, several for our processes as well. Right now, we mainly use it in two directions. First one is on strategic asset management, both of individual asset owners and also as coordinated decision making, let's say. The principles can be used as a framework to apply industrialization through, let's say, portfolio planning, procurement, investment strategies, etc. And for coordination, it gives some sort of a shared language between asset owners in order to create the scale in the demand that we require for industrialization. On the other hand, it can also be used as a diagnostic tool. And this is where we use the principles to identify the missing enabling conditions for a technology. And in this way, we can also contribute or complement the existing maturity models, which is mostly on the side of organizational enabling conditions. All right, to conclude, this research identified 5 foundational principles of industrialization, and from that perspective, it adds a missing system-level perspective to the industrialization research body of construction. In this way, it also offers a shared language for stakeholder alignment, decision-making, and also to understand the enabling conditions for industrialization. And our goal with this is to really help move the ambitions on asset management industrialization to really concrete actions. To talk a bit about the limitations and future work, I think first of all, it's on the broader applicability of this work. This was really scoped in the Dutch infrastructure sector, so we have to see how it fits into other construction sectors, but also other governance contexts. This can be done through empirical case studies, so we want to apply it in more case studies to really understand how these principles interact. In that way, we can also look at the dynamics of principles. So which one have more importance, what is the weight, what is the sequencing, etc., to really contribute to a maturity model. That was it from me. Me and my colleague Alexander Bletsis will be here for the next 3 days, and we would love to talk to you further to continue the work. Thank you.
So thank you very much.